Assalamualaikum and a very good evening to my lecturer and my classmates. So today I will be showing you guys a few examples of how can we apply the equations into some problems. So the first problem is a stone is thrown horizontally from a building of 30 meter high and it is found to land 20 meter away from the base of the building. How long does the stone take to fall? So first of all, we have to bring out all of the informations. Pen pun tak buka. Information which is we have S of 30 meter, and then we have that the stone land 20 meter away from the building. So how long does the stone take to fall? So in here we can use the formula of Sy equals to Uyt minus half gt squared. At initial position of the object, we can say that Uy is equals to 0. So then we substitute Uy equals to 0 into the equation, which will be 30 equals to Uy 0 multiplied by t, we get 0, minus half g, we use 9.81, negative 9.81 t squared, which we want to find. Then 30 is equals to 9.81 times divide 2 is equals to 4.905. 4.905 t squared. And we rearrange the equation. We have 30 over 4.905 and t square root answer, which is equals to 30 divided by 4.905, square root answer 2.5 seconds. So this stone take 2.5 seconds to fall from the building onto the ground. So the second example is a projectile is launched from ground level at an angle of 50 degrees above horizontal with a speed of 30 meters per second. If the projectile is moving over level ground, how long is it in the air before it again contacts the ground? So as usual, first we must take out all of the information given. So we have an angle of 50 degrees and above horizontal, and also initial speed of 30 meters per second. So what the question wants is, how long does the projectile takes to be on air before it contacts the ground again? So first we have to draw a figure to make it more understandable. And the object is here, and this is half of the motion which reach a maximum height, and it will contact the ground here. So at maximum height, Vy is equals to 0. So first, we can use the formula of Vy squared equals to Uy squared minus 2GSy to find the distance taken, find the distance from the initial point to the maximum height, so that we can find the time taken to be at the half motion. So we can substitute Vy is equals to 0 into the equation. So U is 30 sine, remember that, of theta, which is 50 degrees squared, don't forget the squared, and minus 2, and gravity we take 9.81 s. So 30 sine 50 square answer is equals to 5 to 8, negative 5 to 8.1417 equals to 2 times 9.81 is equals to 19.62, negative 19.62 s. So the s is equals to, we move 19.62 to the left hand side, 5 to 8.147 equals to 19.62 is equals 5 to 8.147 divided by answer, we get 26.92 meter. So this is the distance from the initial position to the maximum height. to the maximum height, which will have the time taken of half of the motion. So to find the time taken, we can use the formula of Sy equals to Uyt minus half gt squared. So at initial position here, Uy is equals to 0. Therefore, we can substitute Uy equals to 0 into the equations. So distance is 26.92, which we have found before. 0 multiplied by t will get 0 minus half g t squared. T squared is what we want to find. So 9.81 divided by 2 is equals to 4.905. So we move to the left hand side. 4.905 equals to t squared. Then t equals to square root answer, which is equals to 26.92 divided by 4.905 square root answer equals to 2.34. But remember that this is time taken for half of the motion, which is here. So we need to multiply by 2 to get all the time taken need to fall back to the ground. So 2.34 times 2 we get 4.68 seconds. So that is all the example for today, and thank you for listening, and that's all from us. Thank you.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.